Welcome everyone. Thanks for being here. Today we are going to talk about Quarkus. Not only what it is, but also why did we do it, in which context we believe we needed a solution, what it is and how did we make it happen, and then a bit of the details around Quarkus. So my name is Emmanuel Bernard. I work at Red Hat. I've been on the middleware space for a long time, especially on the Hibernate and data side, generally speaking. And I'm the co-founder of Quarkus. And Quarkus has a bunch of superlatives like supersonic, subatomic, which is a bit pompous, right? But let's see why we think we can make those kind of claims in the Java ecosystem. Okay, so what is Quarkus in practice for you? It's a stack to write Java applications. So if you write Java backends, then Quarkus is an interesting piece for you. While you can write your monolith or microservices, whatever that is, with Quarkus, Quarkus does focus on three things: cloud native, as in where you deploy on a platform that is orchestrating your application, letting you scaling up, down, and define the topology of your application in a fairly easy way, right? So think about Kubernetes or orchestrators like that, which does have this infinite scalability claims, but then the price is embrace the 12-factor applications and those kind of approaches. Microservices, because microservices have two constraints. One is the memory size. We will see why I say that a bit later. And also the patterns. When you have a monolith, the communication pattern is way different than when you have microservices that are likely going to call a lot of other microservices and maybe have to have some sort of event-based approach. And serverless, which is a bit like microservices as far as its constraints and approach, except serverless scaled down to 0, so that when you want to start and execute a function, the startup time to then deliver the response is important. Okay, so that's the context for Quarkus and what it is. And let's stop talking and let me show you a bit what Quarkus does in practice. And what we're going to do is write an application. Okay, so I prepared a tiny bit of stuff. I've got a PostgreSQL database started already, and then I have created a skeleton, a project skeleton with Maven in this case. You can use Gradle if you want to, no problem. So this creates a project with a REST endpoint that we will see. Then I did copy the web resources like the front end of the application, which is going to be a to-do application, because I'm definitely not a front-end kind of guy, so it's better if I copy it from somewhere. And then I just started my ID. And once we've done that, we're ready to get Quarkus started. And Quarkus, one of the first things you will notice is that it's got a development mode, which is very focused in having a sort of a feedback loop between you and the code you're producing. So just do Maven compile, Quarkus dev. We'll sometimes call it the live reload mode. So you see that the debugging has been started with port 5005, so that's the development mode, that's why we start the things. And then Quarkus got started in less than a second with CDI, which is the dependency injection standard, and rest easy. Okay, let's look at the code of the application. So you've got essentially a hello endpoint, which will reply hello when you call it. So fairly easy. If we go to, if we go, there you go, to localhost 8080, we've got a landing page which explains to you how to get started with Quarkus, that you can, of course, remove. And then if we go to the hello endpoint, then we actually have hello that is returned. So far, so good. Now we're ready to go and start coding. So, hello Singapore, go back, I refresh, immediately I see the result. I go back there, let's make it Singapore, refresh, oops. Immediately I see the error. Yeah, I made a typo here, I forget the quotes, refresh, and I see the result. So you see that feedback loop, that's very important for the developer to work on something, see the problem, go back to the code, see the result, and have these no time for Facebook, essentially. That's how I summarize it. How do we do that? We do that, well, by the way, you can do Facebook, it's just explicit, time off. It's not like, because you're forced to do that. So if you look at the logs inside Quercus, you will see change source file detected. What happens is in dev mode, Quercus looks at your Java files and your resources, whether it be web resources, application.properties, other configuration files. And if there is when you do a refresh in the browser, if there is a change, it will compile the Java sources, the Java file, put them in the application, stop the application and restart Quercus entirely, and then serve the request. All of that in 0.2 seconds. Okay? So the JVM stays alive, but we literally get rid of the class loader, start a new one, and then answer the request. That's how you get this Node.js-like feedback loop, except it's in Java. So you get all of the known framework that you have in the ecosystem. Okay, that's cool, but I want to do, well, no, something before. You got tests, and it's the same thing. Because we start so fast in Quercus, the test actually runs the full Quercus application. So here I use rest assured to actually test my endpoint, but I could add inject and use the bean and check them. The one thing I need to do is to add Quercus tests on my unit 5 or 4 tests. And it will actually start Quercus and then run the test and then stop Quercus accordingly. And if you see here, it took less than a second to get running. Of course, if you got many tests, then it's even faster because it gets stuff compacted. Well, not have to stop Quercus and restart it, and so on. Okay, that's cool, but that's just a hello world applications. Let's write a to-do application. If we go back, here, if I do localhost/todo.html, that's the famous front end that I said I haven't written. So it's a classical to-do application that has been designed by, it's one of those implemented in the gazillion of JavaScript frameworks, and also you can write the backend you want. But here the backend hasn't been implemented. So if I do backend and do something, nothing happens because there is no backend. So let's go and implement it. We will want to persist those to-do applications, so let's use a database for that. So I can stop Quercus and look at Maven Quercus list extensions. Thank you. Where? Oh yeah, they are. There you go. It will show you the list of extensions that we have, and a link to the guide and the artifact ID. We've got 40, 50 around, and more to come, whether it be by you or by other people in the community. So let's make it bigger for you to see. So let's add extensions. So there is a Quercus add extension. -d extensions, and then I'll decide. So I said I want a database access, so I need JDBC Postgres. I need Hibernate, ORM, but I will do it with Panache. So I'll explain to you what that is. I want Hibernate Validator. What else do I want? Oh, I want REST Easy, the JSON-B. JSON binding, and I'll also add OpenAPI, and because that will help me for development mode and Swagger UI, and I think I'm good. So it added those extensions, and now I'm back to restart the dev mode, and if we look at the dev mode, it start the applications, and we see more features installed. Agrol is the connection pool for Hibernate, Hibernate ORM, Hibernate Validator, the Postgres driver. Narayana is a transaction manager. We got the full transaction manager starting and running in less than a second, and the rest, okay? So we're ready to code, essentially. So let's go back here. Oh yeah, you see here, enable Autoimport. So this add extension, what does that do? That very simply just add the entries in your POM files. See, Validator, JSON-B, PostgreSQL. That's what it does, nothing else, nothing more. It's just a convenient method to access them. So let's write a to-do resource. Let me make it bigger for you. There you go. So it's a JAX-RS standard way to describe it. So let's say path API that will describe the path. That's the backend of my to-do app that is expected. And I'll tell the application that media type, that I'm going to consume JSON and also produce JSON, because that's how the front end expects the data to come in and out. And then the first endpoint is to actually retrieve all of the to-dos from my database, okay? So I'll just do a get and public list of to-do, get all, the name doesn't matter here. Okay, so the to-do is the Java object that does represent the JSON that is expected from the front end, okay? So I will create that to-do object. And because it's a fairly, don't do that. Yeah, because that's a fairly simple application, that JSON file will also be my, my Hibernate entity, okay? So if you're familiar with Hibernate, you just put add entity on it, and then you're ready to get an entity persisted into your database. And I can frankly get started with that and add inject my entity manager into the to-do resource. So add inject entity manager and then use the entity manager API. But here we're going to use Panache. And Panache has two modes, the repository / DAO mode and then the active record mode, which we will use today. So active record, the way you can think about it is the merge of the repository and the entity itself into one file, one object. So here I'm going to extend Panache entity, and by extending it, I actually inherit the ID, which is interesting because I don't have to type it, and then I can focus on the state of my to-do. So to-do has a title. That's driven by the front end here. I have no choice really. So that's a regular entity though, so I can put column unique equals true. I can use bean validation to validate the constraints. I can put put a URL which is expected by the front end. I'll also know whether the to-do is completed or not, so public boolean completed. And finally, there is priority in the to-do, so I'm going to do a public int order. But because order is a keyword in SQL, I'll just rename the column into ordering. Okay, so I'm ready. Here you see the use fields. You don't have to use field. You can use getters and setters and have explicitly, have them do something. But by default, we use fields to eliminate the ceremony of having, piece of code that is not really relevant for the core of your applications. But if you want getters and setter, it will work. And actually, if you put getters and setter, even if you call from to-do resource, if you do to-do.title, it will be replaced by to-do.getTitle or setTitle, just like Lombok, more or less, in the case of the to-do in the Panache entity. Okay, so we're ready there. Let's make the import class the list of to-do, and then here we want to return all to-dos. Remember, repository and entity are one and the same object, so I can just do to-do.listAll to get all of the resources. But I'll want probably to sort them by priority to focus on the most important one first, so that's what I'm doing here. Okay, I should be good to go. Let's go and refresh, and boom. Okay, yes, I didn't configure my database, right? So Hibernate is complaining, hey, maybe I need a database to work. I'm like, yeah, fair enough. So let me speed dial a bit and copy the database setup. And that's another thing that Quercus does for you, is that it simplifies the whole ceremony around configuration. So instead of a persistence.xml, a beans.xml, a validation.xml, and having to synchronize each of those together, there is one configuration file by default, which is application.properties. And here, just because I put Quarkus database something, and because I put add entity in a file, then Hibernate will be started with the right database context. Well, should be good to go. We refresh. Again, I haven't packaged and redeployed the app. I'm just refreshing, and I've got my to-do, but no information in it because I didn't set up, the database is empty, and I need to set up some fixture. So let's do that. Let's do a bit of speed dial again. Here I've got a few inserts. And I don't know if you know Hibernate, this feature where you can add an import.sql file, and on that one, you can just put your inserts, and it's listened to by Quercus, and when you refresh, you see the data. Okay? So that's right away you see the feedback and get stuff running. I could continue and add the create endpoint, update endpoint, and so on, with add transaction and all of that jazz. It's all working fine. What I will focus on rather is a search engine. So we're going to add a search engine here. So let's make it another endpoint. It's probably going to be a get endpoint as well. Well, I choose to. Then, I don't know, search/word/page, because we want to do some pagination. You know, imagine we got 1 million results. We don't want that to be returned. And then it's a public list of to-do. It's a search operation, and I'm going to receive word and the page, integer page. Then I'm ready to code that. I'm just going to do the binding between the path and the actual attribute. So it's a path param in JAX-RS. Page, okay. And then I can code my search engine. But because it's a fairly complex piece of logic, I'll probably want to put it in the repository so I can reuse it in other places potentially, right? So oh yeah, name. Thank you. Well, you know the funny thing is that if I get that, I've got the error. Yes. Thank you. You're my guardian angel today. Yes, so remember the active record pattern, the entity and the repository is one and the same. So I'll just put the search in it, and I'll do word and page and return. And then see the flow. I'm writing the logic of my application, and then I can use the IDE to autocomplete and keep going in the details. So I'll write an HQL query to express my search engine in this case. So I can use the find operation and then pass the HQL query completed. Let's get all of the to-dos that are not completed. That's probably makes more sense than the already completed one. And then I can say that I want the list for that. And then you might tell me, look, completed false, that's not an HQL query. Well, it is. It is because it's a contextual HQL query. We're in the to-do object, so select to-do from to-do where, it's implied. I can write it, I can do select to-do from to-do where if I want to for a complex query, but here for all of the simple queries we simplify it massively. So you just say completed false, and that's the part of the query. But let's make it more complex because we also want to filter by the world. So that's my first parameter is completed. My second parameter is going to be the title, like second parameter here. And I'll do something a bit nasty. Your DBA won't like that. So I will put, what do you call that? Percent word, percent. Well, the good news is at least I do parameter escaping here, right? The bad news is it's probably going to be a bit of a drag on your real-life database, so please use a proper search engine for that in practice, but here it's for the sake of explanation. Remember pagination? So let's apply the pagination logic. So I can create a page object, a page of, and then the index, page 0, page 1, page 2, and let's say I want 3 results per page, because here I only had 10 or 11 results total. Okay? Well, I think we should get it running, but I don't have a UI for that. There is actually in the to-do app, there is no UI for that. So what's cool is that I added Swagger UI, and Swagger UI exposes your REST API with a nice automated UI endpoint, and I see my default get API, hello, and then API search. So that's all of the results of my to-do, and that's the search engine. So let's do that. By the way, Swagger UI is enabled only in dev mode. By default, in production mode, we just disable it so that users don't have access to that. Hold on, what's going on here? Yeah, try it out. So I'll search Quercus, and I'll get the first page. I got the 3 results as expected, and if I go to the last page, I think it's page number 2 actually, let's execute, I got the last result. So I've written the basic core of my application very quickly, very smoothly, and I could keep going on that. Let's do something more. Let's stop the application and do MVN package, which will create the jar, right? But here I want to compile it natively. So I know some people came from the GraalVM part of that. So native will actually run the GraalVM native executable compilation. So it takes a little while and makes my laptop, fly. So let's keep going on the presentation while this is happening. Actually, I think I didn't update the tests. Yeah, there you go. So I need to go there. Let's make sure it's working. Yep, it's green. Okay, let's start again. All right. So why did we do Quarkus? What's the context? The context is people are going from monolith to microservices and probably tomorrow into functions. When you go into that evolution of model, then there are a couple of things to think about. What's the difference between a monolith and microservices and functions? To me, there are 2 things. One big thing is that the communication pattern, as I was saying, is different. Yeah, there you go. There is more point-to-point communication because the monolith has to talk to, microservices have to talk to one another. So that's extra communication, probably event-based, so maybe you need a broker in between and stuff like that. But otherwise, the programming model, what's inside the box, should be as similar as possible between monolith, microservices, and functions, just smaller and more focused. And for function, the big difference between functions and microservices and monolith is really that the scale down to 0. So the startup time is really important for function because they, as I was saying, they start from 0. So if you take 5 seconds to get started, that's expensive. The other point which is important is that while you can create many microservices and scale very nicely with containers, your dev team is not going to scale to 20x the number of people you had to write the monolith, right? So the 20 people that were working on that monolith will become 20 people working on that microservice, and probably still maintain the monolith while they're at it, right? So for each microservice, all of the extra ceremony, have to wait for tests, have to learn a new technology, potentially figuring out things because there are duplication here and there. All of that is costing 20x the amount of the monolith effort, right? So we need to get to the point much faster with the microservices, not even mentioning functions. But we go for the microservices space for one big reason. We want to be able to update one part of our system totally independently from the rest of the systems. And that has been enabled by this notion of very dynamic orchestrator platform that lets you deploy one application, scale from 1 to 10 instances as needed, maybe even automatically. The key point is to have very clear definitions, contracts between one microservice and another. These are the red boxes between the various islands of microservices. But the key is that I can literally rewrite entirely microservice number 2 without affecting microservice number 1 and 3, and maybe change the database from Oracle to an in-memory database just because I have some scalability needs or response time needs, right? And that's not going to affect the rest. If you had a single monolith, then having to rewrite the backend entirely is a lot of work and probably not something that would happen. So that's that flexibility. You will not deliver more features per unit of work, but you will deliver faster the features that do matter because you can focus on what you need to work on. So let's go back to Java. Remember, when you say, okay, Java, I can make a smaller app by using XMX to 30 meg or something like that, it's actually a bit of a lie. The Java, that's true. The XMX is actually the heap size. And the heap size of Java is just a small part, it's just a part of the total Java process size. Heap size is your application data, really, right? And when you go for very small applications, like when you try to touch the 30 meg, 25 meg, 5 megs of heap even, Quercus can start with 5 megs of heap on a REST application, by the way. The RSS size, the rest can take quite a bit of space comparatively. So for a 30 meg heap size application, the stuff I've managed to test had a meta space, the other space of like a total of 250, right? So that's 250 RAM used instead of the 30 you expected to use, right? And that's important because containers, what matters to them is not the small part of the heap size, it's the total size of the process. It's called resident set size. And if you go above a limit, they just kill you, right? So that's the important aspect. Also, if you do lots of small applications like microservices and your meta space comparatively to the heap size is big, then you've got a fixed size that is expensive the more microservice you have, right? So that's the other problem. Why is it happening in Java, by the way? Java has been optimized for requests per second to really be as fast as possible in throughput. And that was at the expense of memory usage and startup time. Okay, they made trade-off, which was fair in the 90s, end of the 90s, but in orchestrated and containers, the logic is more to say, I can go up to that many requests per second on this one instance, so I can create 2, 3, 4, 5, 10 instances. So that's a different way to scale, really. And the reason that it's happening is that the metaspace is really owning a lot of the class usage, class metadata information. Which part has been compiled, which part is compiled in memory, kept in memory, which part has been, is dynamically linked to another piece of code, what are the relations between a class and another, so that if I have to recompile a part, maybe I need to optimize things, and so on and so on. That is what's taking a bunch of the metaspace space. So if we go back to our microservices, then some people are moving away from Java, first of all because of this absence of live reload. The other problem is because you have a fixed size, or it's not quite fixed size, but you've got a big overhead for small heap size that is becoming prohibitive as far as resource consumption. That's what Quarkus is aiming to fix. Let me skip that one. So what is Quarkus? In practice, Quercus, well, first of all, the name comes from the elementary particle, and then, trademarks and whatnot, you need to make something unique, so you need to put something after the name. We got four benefits, really. One is the developer joy. You've seen the live reload, this very fast access to get you to the task and be done and go on Facebook. The other focus on this is a very important aspect of Quarkus, focus on the developer mindset. So you're based on stuff you know already, whether they be standard or de facto standard as far as libraries, but we simplified the configuration, not 5 different configurations that have to be synchronized with one another. It's just one configuration that unifies everything. There is the live reload with 0 configs. It's not a plugin in my IDE or anything like that. It's just Quarkus column dev, and I'm ready. And you've seen with Panache. Panache is really a layer on top of JPA. You don't have to use it, but when you use it, you can get the CRUD operation and the simple queries much, much faster than, code-wise than you would otherwise with plain JPA. And also the native image generation. By the way, speaking of, the native image generation is done. It took about 2 minutes. If you see the command line here, that's what you need to pass to GraalVM to get an image running. And by the way, it does reference some other external files, so it's actually more like this. But when it works, it's great, because if I look at my target here, I've got a runner that I can put in my Docker image and do java.-jar and then pass that jar and run in normal hotspot, normal OpenJDK rather. But I also have this thread file, which is really a native executable for the platform I'm running on. So in this case, target, Voxxed. Voxxed Quart runner, I get running. By the way, it started already. Let me do it again. Started already. 0.05 seconds. Well, it's not me, it's GraalVM really. That's great for the startup time I was mentioning. The other advantage is, you remember the RSS 250 for an application? If I go here and I do x minus o, what is it, RSS command, and I grep by Quercus, you've got, where is the baby? Huh? I don't see it. It's too bad. Let's say Voxxed. Oh, because it's not called Quarkus, that's why. There you go. The Voxxed application, there you go, 29. So it's in kilobytes. So that's 29 megabytes used instead of the 215 traditional way to get stuff running. All right, let's go back to the benefits. The second benefit is actually the size that I was mentioning. If you take an app run in the classical way to write cloud-native application today in Java, the best you can do with a REST endpoint is 140 megs of RSS, not just heap size, RSS, okay? That's what matters. If you take Quackers on OpenJDK, you get half that. Half is better, right? It's not like half as good, it's like twice as better. And then if you go for native image compilation, which takes a bit of time, right? The 2 minutes can go to 3, maybe 4 minutes, 5. You got a 10% of the memory usage. That becomes very interesting for the density inside containers. You might tell me, REST endpoint, that's just cheating because that's too simple. So let's make it with a Hibernate backend and accessing the database. That's a more realistic application. Same comparison. Not twice as good, but close to, and not 10 times as better, but close to. So that's a big difference here. The other big difference is startup time. Actually, not startup time, it's actually time to first response, which is what matters, not only because if you do serverless, you're paid by the CPU time you spend, so by the time the request has been rendered to the user. So that's important. But even in microservices, that's important. Even for your test, that is important, because you want to test and be done and see the result right away. So the faster you are, the better. So if your framework is doing too much lazy stuff, and then load stuff when it actually does the first response, that's cheating. So we wanted to avoid that. You see the differences. So you see, first of all, even in OpenJDK, massive improvements. But when you go with GraalVM and native image, you go to the 50 or even tens of milliseconds. The third benefit is the unification of imperative and reactive. Reactive is very important, again, for the scalability and the density of your applications, especially in the case of microservices which are event-based and need to be essentially reactive systems. So reactive applications and reactive systems are different, but they go hand in hand together. You want non-blocking way, back pressures and stuff like that. So here with Quarkus, you essentially use the same programming model with just different return types, and then you got the reactive version of the stack. And we try to unify that for you. The last benefit, well, there is many, but the 4 I want to mention, is that the way you write Quackers is a REST-easy application with JAX-RS, a Hibernate application with the JPA APIs, the Camel application, Vertex applications, right? So these are the APIs that you see and are exposed to you. These are not Quercus APIs. These are APIs you already know. So you already do have a couple of years of experience with Quercus without knowing. It's even the benefits. So let's go to GraalVM. What really made us see the lights, let's say, we've been fighting this memory usage to make Java applications cloud native for quite a while at Red Hat, trying to optimize, discuss with the OpenJDK team, which we have some key members in-house, and really fight. Middleware was like, guys, you take too much meta space, and they come back to us, guys, you use too many classes, and we're trying to find a solution. GraalVM really made us, because of that experience, we saw GraalVM as the enabler. But GraalVM is many things. It's kind of an umbrella project with many things, including the polyglot aspect, the truffle aspect, which is running other languages on top of JVM. What we're interested in today is GraalVM as far as the Java library, the Graal compiler. The Graal compiler is like the hotspot C2 compiler that takes bytecode and compile it to the native CPU that you're using, physically underneath. Graal is a C2 rewritten entirely in Java, which is more maintainable, and therefore they can add more optimizations. I think there is another talk around GraalVM, around the Graal compiler here at the event. And Substrate VM is what we use underneath for Quercus. It takes the Graal compiler and says, okay, I'm going to take the whole jar, the whole application with the jars, and compile this bytecode into native executable at real time. Not just in time, on the fly, and only the pieces that matter. Everything at real time, so that what I've got is an actual native executable. I don't have a JVM that I run bytecode on. The bytecode is gone. Okay? It still has a garbage collector, by the way, but it has no just-in-time compiler because everything has been ahead of time compiled. So how does GraalVM makes those massive memory optimization and startup time? In two things. The first one is there is no JIT, right? So there is no metadata around the classes and what has been compiled and not compiled and all of that, because that is already in the code, right? So all of the JIT metaspace is gone. Big benefit. The other big benefit is the dead code elimination. If we were to compile the full JDK plus all of your frameworks plus your actual application, that would take quite a bit of space. But here they do dead code elimination, meaning they take the root of your application and navigate all of the possible code paths. Okay, I can go there, and this application, and this piece of the methods, and so on. Everything that is not seen as a possible path is eliminated. That's what it means, right? And the way they do that is by having a closed world assumption. At real time, I assume that I have all of the code that will ever run in that application. And I make it, and I do an analysis based on that. So all of the JDK that I don't use is not going to be in the native executable in the end. That's how we make the big memory benefit as well, and startup time. So with this closed world assumption and the great benefit comes a bit of a dark side. I won't have time to go to all of that, so I just took the good parts of the bad side, the dark side. But it's still impacting for the Java ecosystem because this is not what we're used to. First of all, no dynamic class loading. No way to say, okay, I've started my app and then I'm receiving a new class and I will load it on the fly and then execute stuff, right? Like a dynamic language would do. This doesn't exist. Actually, there is no class loader in Substrate VM, period. Okay? So, and why is that? Because we have compiled everything at real time, right? We have the closed world assumption. If you bring us new code after the closed world assumption has finished, then you don't exist as code, right? The other caveats more practical for the Java ecosystem is there is no reflection everywhere you want. You cannot do arbitrary reflection just like you're used to in Java, into JVM. Why? Because think about the closed world assumption and the dead code elimination. If I can do reflection everywhere, potentially, it means I can invoke any piece of code potentially, which means every piece of code has to be compiled because of that potentiality. So that would kill the whole dead code elimination aspect. So we would have to just get rid of that optimization. So instead, they said, okay, no reflection for you unless you give me the list of classes or methods or even fields that you want to do reflection on. That ends up being a big, massive JSON file. Imagine your app where you do reflection. Imagine a framework like Hibernate where it does reflection. Imagine a framework like a dependency injection framework like Spring where it does reflection, and so on, and so on, and so on. The Java framework ecosystem is essentially based on class path scanning and annotation and discovery and all of that. Same for dynamic proxies. You can have proxies, but you have to know the interfaces ahead of time. I'll skip static initializer, but know that some static blocks can actually be executed eagerly instead of lazily, which is a bit of a showstopper for some frameworks that rely on that to lazily load optional dependencies and stuff. So the ecosystem has to evolve a bit. Lambdas and thread, they're working. Not invoke dynamic, but lambdas and thread are working fine. All right, so how does Quackers work in practice? We took frameworks, and we said, okay, what do? They parse config files, they do class path scanning to detect the add entity in the case of Hibernate, so they scan the whole class path, and then they do, inside each class, find the getters, the setters, and whatever metadata they need. Then they actually build an internal runtime model which does express, which is used at runtime for, in the case of Hibernate, for a given class, here is the SQL query to persist, SQL query to update, and so on and so on. And then we prepare reflection. We create the method objects and whatnot, and then we create the proxies and whatnot. And finally, we start the framework. So all of that work, except the last line, we will do at build time in Quarkus instead of startup time. That's the big difference. So there are a couple of benefits, many benefits. One is, instead of doing it every time you start, you do it once. So the startup time got a big benefit from that. The other advantage is that frameworks, there is actually a bunch of code that does bootstrap operations. Hibernate, Spring, everything. There's probably at least 50% of the code in practice that is doing a lot of that. So since we boot at build time and we just start at runtime, all of those boot time related classes are not loaded. We don't need them, no space in the JIT, less class to load, all of that is optimized that way. So less time to start, less memory to use, and also because we know where we want to do reflection, Hibernate knows it needs to do reflection on add entities, we can either generate the equivalent of the reflection or generate the proxies instead of having them generated at startup time. So that's another speed benefit. The other one is, remember GraalVM, they let you do reflection only on the classes you explicitly express. By the way, something I didn't say is the dead code elimination is very fine-grained, up down to like each instruction. Do I need this if clause? Do I not need this other part, right? So that's very fine-grained, not just class at class level. So GraalVM requires you to have classes for, express classes for reflection. And frameworks, like Hibernate, like REST-easy, they know which class you need to do reflection on because you need to do persistence on them, whether it be serialization via JSON or accessing getters to then put that in the database and so on and so on. So we can actually the framework pass that information to the GraalVM without you as an application developer having to write that down. And the other effort we do is we minimize the dependency. So the dead code elimination that the GraalVM does, we do the same with Quercus, but at the framework level. Oh, we know you don't use second level cache. Let's eliminate entirely. Let's help the whole part of Hibernate that deals with second level cache. Let's eliminate that code, right? We help the dead code elimination logic to really go one step beyond and have even a tinier memory usage and startup time and so on. So Quarkus is everything that's in blue. You've got the core, and again, 80% of that work is actually done at startup time, at build time, rather. So Quarkus is essentially a stack that has a framework that lets other frameworks start at build time. Okay? It's really a facility. So I won't go into the details of the inner facility, but the extension model is very important because that's the way you integrate a framework that you want to expose to user with the Quarkus way of doing stuff at build time and having this super nice live reload and simplified configurations and whatnot. So you see REST-easy. REST-easy has a dependency on the actual REST-easy project and does the build time, startup time of REST-easy, the framework. So that's a bridge between Quarkus and the REST-easy framework. Same for Netty and Hibernate ORM, Hibernate Validator, the microprofile, small Y implementations, and so on and so on. The build process is you compile, you've got your .classes files, then you make a jar out of that. Then the provisioning phase is really getting the right version of the frameworks you want. Then there is the whole execution of the extension, wiring, like detecting which entity exists, which one needs to be enhanced with proxyable and whatnot, pass the information for reflection to GraalVM. All of that information is done at build time once. And then you decide, either I run it on OpenJDK and get a 2x benefits in memory usage, or I go the extra step of native image compilation and then go for these even more advanced optimizations. All right, let's go a bit more on Quarkus. Testing, we already saw that. It starts really fast. it starts the full Quarkus application, and you can get injections and so on. So you're really testing the real thing, not just having to mock to speed things up. This is the entity with Panache in a summary of it. You see the queries that are very contextualized HQL queries. You can use the repository pattern if you want to with Panache. These are the two differences. You see that you have to add an extra class that extends Panache repository, and then you just inject the repo, and then you go and use the repo instead of having everything on the to-do. So it's really a choice that you have to make as a team. We have observability, whether it be via OpenAPI, exposing metrics, exposing the health check, which is really important for those orchestrators because they need to know whether your app is alive and ready or not, and they have this health endpoint that they typically check to try and see that. So having a nice way to offer that is useful. Database schema migration, we've got a Flyway integration. We've got a very nice Kafka, AMQP, MQTT support, and so on, Stomp, all of that jazz. We use it via an abstraction called microprofile reactive streams. Reactive messaging, rather. It's very nice to add incoming, add outgoing, and you get incoming results with a reactive object or not, and get going, and then can push message out. This abstracts you from Kafka and AMQP and so on, but you can create a Kafka message to then go down to the index and whatnot if you want to do Kafka stuff. You can secure your application with the @role allowed and secure your application really using JWT tokens, delegate that to Keycloak if you want to, like a service, a very well-known pattern in the 12-factor application. Don't do your own stuff, delegate to services whose job it is, right? And finally, if you find that a library that you use and would benefit from Quarkus integration does not work, well, first of all, you can just add it as a dependency and it will run fine with OpenJDK. It might not work fine with GraalVM. That's maybe up for debate, depends on what the library does. But when you do an extension, you really make it a Quarkus experience with having all of the configuration in the same file, doing the start at build time to benefit from the memory optimization and startup time optimization. So all of that is the benefit. So if you see a framework you like, you do the extension once and everybody benefits from that ecosystem. You know what, I'll skip the future. The future is very much what you're going to tell us and react on Quarkus. We are defining the roadmap. We've got our own goals that we think are matching what you're looking for, but come and tell us what you really need and we will definitely adjust the roadmap because that's what matters really for you to write Quarkus applications and get faster with the library load and all of that. So let me go fast on that. Remember, Quarkus, developer joy, super compact in memory usage and startup time, which is great for orchestrated environment like Kubernetes, OpenShift, and have super low startup time for serverless, or even the instant scalability of your platform. The unification of imperative and reactive to not have to think about it as two different stacks, right? And of course, all of the libraries that you know and love, we have or will have extensions for them, so they are actually visible and exposed into Quarkus. So please give me feedback on that presentation, and also if you go to the Red Hat booth and fill up one of those red forms, then you can get a free book and other stuff. There is lots of Quarkus stickers in the booth, so come and enjoy and pimp up your laptop. Thank you very much. Let's open up for questions. We've got about 5, 6, 7 minutes of questions. Yeah?
Yes. Which is the support for JVM and Scala?
Yeah. So the question is there support for other JVM-based languages like Scala and Kotlin? So we do have an explicit Kotlin extension where we offer support for that. We haven't done any Scala efforts specifically. I don't anticipate Scala to be of a problem on GraalVM because they do so much stuff ahead of time with the higher level, language approach that they have. But nobody has really, done an extension right now. It's to be checked. But there's nothing conceptually that prevents that, for sure. I've seen other people actually use Truffle to communicate and do Quarkus app and call them from JavaScript and all of that. I haven't done it personally, so I don't know how much that is doable and exportable. Other question? Yes?
Just wondering, is there any sort of like concern effort to actually push some of this native image support upstream to the libraries? Because I've had some success building the native image app, but most of the time when something's not working, I have to sort of like come down to, say, the Quackers people, Microservices people, to actually figure out how actually make these things work.
Yeah. So is there an effort to make libraries run on GraalVM like upstream? So that's a great question. So let me backtrack a little bit. So there are some cases where Substrate VM would not run the classical way library would run, like things like even the service locator patterns actually not working out of the box where they have some support. But so you need a bit of help from the library. So you got three ways. You got three ways to do that. One is upstream in the code, the library would actually update so that you can make it run. The second one is using GraalVM substitution model, which is essentially a patch. It's a piece of code that says, when you see that method, please replace that method code with that other one. And that you can put upstream as well. So it's upstream but as on the side, which means it doesn't pollute the core of the upstream application. And the GraalVM guys have created some sort of a static model to express that. And the third one is having the substitution at the extension level for Quercus. So as much as we could, we did it upstream. Like for Hibernate and Hibernate Validator and all of those, we did it upstream. For PostgreSQL driver, we did it upstream as well, as much as we could. Sometimes we need substitution because the change is a bit too ugly, and then it's up for the upstream community to accept that change or not. And some substitutions are really focused on the closed world assumption of the application. So Quarkus would know, okay, there is no second level cache, so let me substitute stuff so that the whole piece of code is simplified so it doesn't exist. That doesn't really live in the upstream, right? So that's the complexity. It's very much work in progress. I would love and the Micronaut too, they would love as much as we can to put stuff upstream to avoid duplication of that effort. Because for anybody that had to maintain a patch of a library that was evolving, nobody wants to do that in its life. Okay, another question?
Yeah, one more.
Hold on, there's this gentleman and then I'm back to you. Yes? Can you speak a bit up? So if I understood your question, because I didn't hear everything, you said the website says I need to use GraalVM, I guess in the getting started here. So, okay, there used to be optionally, you will need, it's for native applications. So you don't have to make native applications, therefore you don't have to use GraalVM, right? So, yes, what the benefit you saw here, so this is in pure OpenJDK. You don't need GraalVM for that, right? To go from there to there, this is just pure OpenJDK. Oops, sorry. What did I do? There you go. Same here, right? And same for those. If you want to go for the LightGreen, then that's when you need GraalVM to go for the native image compilation. Frankly, it depends on the size of the core of your data that the application will use, right? If it's really a request-response application like a REST endpoint and so on, Quarkus OpenJDK, but even more the GraalVM approach will be very optimized. If somebody was mentioning a Spark, something that uses lots of data in the heap space, then the ratio between the meta space and the heap space is less interesting, and then you're better off staying on OpenJDK and really benefiting from the just-in-time compiler that can do even more awesome stuff than a static compiler ahead of time. Same for better garbage collectors and options and so on. So yes, you can run Quarkus in OpenJDK 8 or 11, and all of the other flavor of JDK, right? Adopt OpenJDK and all of that. But you can use GraalVM for the native image compilation to go one step further on those small native image. Right, but essentially the fact that we move stuff at real time with Quarkus really made it, we aim to run on GraalVM, but it made the OpenJDK run much better as well, with much less memory usage and better startup time.
Sorry, just a question on the earlier slides about the caveats. I noticed...
about what?
One about the caveats on the...
Yes, on GraalVM.
Lambdas and threads. Could you elaborate more on that?
Which one?
The lambda and threads.
Oh no, it's actually not. So yes, I probably should remove it. Right. So it's just that invoke dynamic as a general framework doesn't work because of the dynamic class loading magic and so on. But they did a trick to make lambda works. And lambda in JVM, in normal JVM, actually relies on invoke dynamic, not in substrate. Okay? It's just that lambda, I mean, nobody wants to go back to the anonymous classes, right? So we want it. And threads are like an essential part of Java. So they work. That's what I meant to say. So pretend the line wasn't there. Probably should fix that. I think there was one question over there from a gentleman. Well, he gave up. Okay. Maybe one last question before we free the room? Okay, thank you very much for attending. And I'll stay here for the rest of the conference, so come and talk to me.